Meet HoudiniMind, an autonomous AI agent designed to bridge the gap between natural language and complex 3D production. Let's watch it build and iterate through direct text commands. We start with a simple request. Please create a table. The agent immediately begins planning the scene, drops a geometry container, and procedurally generates a clean table in the viewport. Next, we move into FX territory. I tell the agent to fracture this table. It understands the technical requirements instantly, automatically setting up an RBD material fracture and an RBD bullet solver, expertly preparing our geometry for high-end physics and structural simulation. To test the simulation, I type, please add a sphere animation up to down. Now initially, the agent created the sphere but missed the animation. I had to step in and tell it, you didn't add the animation. Once it realized the mistake, I followed up with, you have to be truthful. This is a key part of the workflow. The agent acknowledges the error, corrects the keyframing, and successfully drops the sphere onto the table. It demonstrates that the AI isn't just a black box, it's a collaborator that listens to feedback. Watch as the table finally reacts to the impact, with gravity and collision geometry now working in perfect sync after the correction. I wanted to change the physical properties, so I simply typed, I want wooden pieces, not concrete. The agent immediately updates the fracture logic and visual shaders. You can see the pieces now splinter like wood rather than crumbling like stone, perfectly reflecting the new material behavior I requested in the chat. When I ask what else we can do, the agent provides a list of intelligent suggestions. I choose to increase piece count for finer wood splintering. The agent resimulates the high-resolution wood splinters seamlessly, managing the heavy lifting of the node graph behind the scenes. It's not just for basic fracturing. Here, I task the agent to create a spiral staircase. It writes custom VX code on the fly, handling the mathematical distribution of steps and the height offsets. When I tell it to look at my viewport and analyze, it's not in spiral shape. The agent identifies the logic error in the code and fixes it immediately in seconds. Finally, let's look at procedural tool building. I ask the agent to create a ladder. Once built, I give it a specific constraint. I want you to link left rail height with right and make sure when we increase height, it won't increase minus y-axis. The agent builds the logic and links the parameters so the system stays responsive. However, the rungs weren't quite right. So I told it, now I want run should be properly distributed. Right now it's not proper. The agent calculates the spacing and fixes the distribution. To make it even smarter, I commanded, you have to link it so that when I increase rail height, rungs should automatically increase or decrease. As I increase the height, you can see the rungs being generated dynamically. The agent is building a smart asset, writing the expressions needed to ensure that no matter the height, the spacing stay consistent. This is the core of Houdini, proceduralism, made accessible through natural language. No more getting stuck on why an expression isn't working. The agent handles the logic, allowing you to build complex, scalable tools. It even handles the network cleanup, ensuring the attributes are passed through correctly for rendering or further simulation down the line. To wrap it all up, I asked the agent to convert my ladder to HDA. It packages the entire logic into a professional digital asset, creating a clean UI folder with custom sliders for height, width, and rung thickness. This is the future of technical direction. From a simple text prompt to a production-ready, reusable tool. This is the power of HoudiniMind.